Okay, today we're going to talk about graphing linear inequalities. So previously we've talked about graphing equations. So a quick little review here. We need to solve for y first. Then we start with our y-intercept. So I would put a point at 4 on the y-axis. Then my slope is a negative 1/2. So I'm moving down 1 over 2 from that initial starting point and using those points to make my line. My first vocabulary word is linear inequality. So this basically is similar to an equation, but it will contain our inequality symbols. So less than, greater than, less than or equal to, or greater than or equal to. So it's going to have one of those. We're going to have to shade. So let's look at what that will look like. So we're going to look at the 4 different types of graphs here. So first we're going to look at y is greater than 2x minus 3. So this portion we're still going to graph the same way. I'm still going to start with that y-intercept of negative 3. And then my slope is a positive 2. So if my slope is a positive 2 over 1, that means I'm going up 2 and to the right 1. So from this point, I go up 2 over 1, up 2 over 1, and I'm going to do quite a few points here because I want to make sure I cover my graph. And then I can also go down 2 to the left 1, okay? So there's a good amount of points to start with. And here, because this is just a greater than sign, y is greater than this line. I don't have the greater than or equal to. This is going to be a dashed line. Okay? So when I make this line, I'm just going to make it a dashed line. I'm not going to connect the dots with a solid line. Okay, that's why it's important to use a lot of points. Now, I split my y-axis into this top portion and this bottom portion, okay? From that y-intercept, it's split my y-axis into those two pieces. So if I'm saying y is greater than this equation, I want to shade where the y values are bigger than this y-intercept. Okay, so you're kind of thinking like a number line. Here is a negative 3, then we have negative 2, negative 1, 0, 1, 2, and so on. And if I go down, they're getting more negative, right? So if I want to shade where y is greater, that's going to be this portion of my graph. So that's how I would shade. The next one we're going to do less than. So graphing that line is going to be the exact same. I'm going to start at negative 3 and go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, just getting all those points on my graph. Now I have less than. And again, I don't have that or equal to line, so that means this will also be dashed, a dashed line. Okay, once we get that line down, then we can decide where we're going to shade. So again, I've split my number line into two pieces. I have this bottom portion and then this top portion here. So now I'm wanting to shade where y is less than that y-intercept. So I want to shade the values of y that are smaller than negative 3, so that would be in this direction. So I'm shading beneath the line, okay? When I graph this line, it splits my grid into two pieces. I have this piece up here, which is this whole area, and then I have this bottom section here, okay? The bottom section contains the yellow piece of the y-axis, and then this piece over here contains the top piece, or the more positive numbers. So if I want to shade where y is less than, that's this part of the axis which is contained beneath my line. Okay, so I'm going to make sure I shade this whole side of the graph just like that. The next one I'm going to do is y is greater than or equal to. So again, line is going to be graphed the same, starting at -3 up to over 1 for all of those points. Okay, just getting a few on here. Now here, for this inequality, I'm saying y is greater than or equal to. So I have that or equal to part, so that means I'm going to have a solid line, okay? We're including these points, so I want to make sure my line is solid. Just like in the last couple of sections, when I had greater than, this would be an open circle, right? That circle was not filled in. Neither is our line. Our line is not filled in. Now that I have greater than or equal to, if I were graphing this on a number line, the circle would be filled in. So my line is filled in and it's going to be solid. Okay, then we have upper piece of my number line, lower piece of the number line. Y is greater than or equal to, so my y-axis is greater than or equal to up here. So I'm shading that side. And then last we have less than or equal to. So our line is the same here. We have the same y-intercept, same slope. Because here it is a less than or equal to, I'm going to have that solid line. Okay, so here is my solid line. And I have my lower y-axis where my y values are smaller and upper where my y value is bigger. So if y is less than, I'm going to shade below. Okay, so those are our 4 different types of graphs. You can see when we have greater than and less than, I have those dashed lines. Greater than or equal to, less than or equal to, I have solid lines. And then you can see the shading similarities when we have greater than or equal to, and less than or equal to. Okay, here I'm shading below, here I'm shading above. Okay, so use this as a reference for your line, whether it is dashed or solid, and where we are shading. Okay, so to find the region to shade, that's our goal, is we need to figure out where we're shading. But we need to do a couple of things first. We need to make sure our inequality is solved for y. Okay, so we need to have y by itself. And then you have to make sure that you shade, okay? This region is our solutions. Okay, the whole entire region is our solutions. So if I'm looking at this first one here, I already have y by itself, so I don't need to solve anything. So I'm going to graph this with my slope and my y-intercept. So I'm starting at -7, and my slope is 3, so I'm going up 3 over 1. And I'm going to put a couple of points on this graph. Okay. Now this is a less than problem. It's not less than or equal to, so this is going to be a dashed line. Okay. So there's my line. Once you have your line graphed, now we're just looking at shading. So y is less than this line. So I have my lower half where y is smaller, and I have the upper half where y is bigger. Because y is going to be less than my line, I'm going to shade where those y values would be smaller than that y-intercept. So the smaller values are down here on the y-axis, so I'm going to shade this side of my graph. Now for b, I'm going to have to solve this for y first. So I'm going to copy this over. X minus 2y is greater than or equal to negative 6. So I'm going to subtract x from both sides. I have negative 2y is greater than or equal to negative x minus 6. And then to get y by itself, I divide by negative 2, and I'm dividing everything by negative 2. So I have y, I divided by negative numbers, so I need to flip that sign, is less than or equal to 1/2 x plus 3. Okay, negative 1 over negative 2 reduces to a positive 1/2. Negative 6 divided by negative 2 is positive 3. So to graph this, I'm starting up at positive 3, and I'm going up 1 over 2. And same thing in the other direction, down 1 over 2. And this is less than or equal to, so my line is going to be solid. And you want to make sure it covers your whole graph. Okay, so make sure it's long enough so you can see those two sections. So y is going to be smaller in that lower portion and bigger in the upper portion. So if I want to shade where y is less than this line, I'm going to shade the bottom. Okay, now we have a couple questions going along with these. So my first question for part A is the point 4, 5 a solution to the system? So if I plot 4, 5, I'm going to go to 4 on my x-axis and 5 on the y. So if I plot that point, that is a point on the line. Okay, so 4, 5 is on the line. And we're trying to determine if it's a solution. Since it's on the line and the line is dashed, this is not a solution. Okay? The dashed line is just like an open circle, meaning we do not include those points that are on that line. So we would not include this. This is not a solution. Now if I look at the next one, negative 5, 2. Negative 5, 2 is all the way over there. That is nowhere close to the area that I have shaded. So that would not be a solution to this as well. We could say no, not in shaded area. Okay? Now if we look at B, the first point I'm asking about is 4, 5. So here's this point. Again, we're on the line. So we'll say 4, 5 is on the line. Here though, the line is solid. So we could say, yes, this is a solution. Okay? So the difference here is that if you have a point on your line and the line is dashed, it is not a solution. If you have a point on your line and the line is solid, then it is a solution. And then the last one is 0, 2. 0, 2 does fall beneath my line, which is in the shaded area. So yes, that is a solution. And we could just say yes, 0, 2 is in the shaded area. Okay? Go ahead and try those two You Try Now problems on your own. Remember, this one just has a Y, so it's going to be a horizontal line here. And then go ahead and do your homework. We will talk about the You Try Now problems in class, and let me know if you have any questions.